Hey everyone, in the previous video we understood what Java is and why Java is one of the most popular programming languages in the world. We also saw why banks, large enterprises and backend systems rely heavily on Java. Now let's understand when we write a Java program and click the run button, what actually happens behind the scenes. How does the computer understand our Java code? Because computers don't understand Java. Computers only understand zeros and ones, which is a machine code. So there has to be process that converts our Java code into something the computer can execute. That's what exactly we are going to understand in this video. By the end of this video, you will clearly understand how Java code gets executed, what JDK is, what JRE is, what is JVM, and why Java is called platform independent. So let's start. Before we learn what JDK, JRE, and JVM are, first let's understand the entire journey of a Java program. Once you see the bigger picture, all the three terms will make much more sense. Whenever we write a Java program, the process looks like this. We write the Java code inside .java file. Then it is compiled using Java compiler. After compilation, it is converted into bytecode, which is .class file. Then it is sent to JVM, from JVM to operating system, and then the output is printed. So every Java program follows this journey. Now we will understand each step one by one, and then we will see where JDK and JRE fits into this process. As a developer, we write code inside a .java file. For example, this main method, this main class, and this main method. This code is written in language that human can understand, but computer cannot understand this code directly. Since computers only understand machine code, something needs to translate our Java code. That translator is called as Java compiler. Java comes with a compiler called javac. Its job is very simple. It converts Java source code into bytecode. For example, this main.java file will be converted into main.class file. This class file contains the bytecode. It is not directly converting Java into machine code. Instead, it converts Java into something called as bytecode. You can think of bytecode as a bridge between Java code and the machine code that computer eventually executes. This is one of the biggest reason Java became so popular, because bytecode is platform independent. Now let's understand what is bytecode. So bytecode is an intermediate language. In simple terms, it is a common language that every JVM can understand. So instead of generating separate machine code for Windows, Mac OS and Linux, Java generates one bytecode file. The same bytecode file can be run on machine that has a JVM installed. This is why Java follows the principle write once, run anywhere. Let's understand this with an example. Imagine there are three developers. One uses Windows, one uses Mac OS and other has Linux. And every operating system has its own implementation of JVM, which is Java Virtual Machine. In some programming languages, you may need separate executables for different operating systems, but Java does something different. It creates one .class file or bytecode file. Then every operating system uses its own JVM to execute that file. That is why same Java program works everywhere. Now let's see about JVM. JVM stands for Java Virtual Machine. It is a virtual computer that sits between Java and the operating system. You can think JVM as an execution engine because its main job is to execute the bytecode. It reads the bytecode and converts it into machine instruction that the operating system can execute. The process looks like this. Bytecode, it is sent to JVM. JVM converts it into machine code, and that machine code is sent to operating system and output is printed. Every operating system has its own implementation of JVM, like Windows has its own JVM, Mac OS has its own JVM, and Linux has its own JVM. The Java code remains exactly the same, only JVM changes. This is the reason Java is platform independent. At this point, you might think the JVM only executes the bytecode, but it actually does much more than that. Let's look some of its responsibilities. First is memory management. So whenever objects are created, we will see what are objects and classes in later videos. For now, just understand that whenever objects are created, JVM allocates memory for them. Garbage collection, like JVM automatically removes the objects that are no longer being used. Security, JVM provides a secure environment for running the Java application. JVM also helps to manage runtime exceptions, like whenever unexpected situation occurs while program is running. JVM manages multiple threads when application performs multiple tasks simultaneously. And modern JVMs also optimize code execution using something called as just-in compiler or JIT. We will learn about JIT in a future video. For now, just remember that JVM is much more than just an executor. It is an entire runtime engine that manages many important tasks behind the scenes. Now let's see about JRE. So far we have understood about how Java code gets executed and what the JVM does. But here is another question. If JVM is responsible for running Java programs, then what exactly is JRE? So JRE stands for Java Runtime Environment, and as the name suggests, it provides everything required to run a Java application. Think of it this way, like if you want to watch a movie, you need a video player. You don't need a video editing software. Similarly, if you want to run a Java application, you need JRE. JRE contains JVM, core Java libraries and supporting files. JRE does not contain Java development tools. It only helps in running the Java applications. A simple formula to remember is JRE is equal to JVM plus libraries. Now, what is JDK? Now we know what JRE is, but as a developer, we don't just run Java programs. We also need tools to write, compile, debug, and manage our applications or package our applications. That's where JDK comes in. JDK stands for Java Development Kit. This is what developers install. JDK contains everything required to develop Java application. Like it includes JRE, compiler, debugger, and development tools. Think of JDK as a complete toolbox. Like whenever you write Java code, you install JDK. So the simple formula is JDK is equal to JRE plus development tools. Some development tools are javac, javadoc, JDB, and jar. You don't need to memorize all of them today. Just remember that JDK contains tools used for development. What is the relationship between JDK, JRE, and JVM? So this is the easiest way to remember. Like there is a JDK, inside it there is a JRE, and inside JRE there is JVM present. Or JDK is equal to JRE plus development tools, or JRE is equal to JVM plus libraries. Like every JVM is inside JRE and every JRE is inside JDK. If you are a user who only wants to run a Java application, you need JRE. If you are a developer who only builds Java application, you need JDK. Since JDK already contains JRE, developers usually install only JDK. Now, why Java platform independent? This is one of the most frequently asked interview question. Many beginners answer because Java uses JVM, but that's only partially correct. The JVM alone is not the reason. Bytecode also plays an equally important role. The complete answer is Java is platform independent because Java code is first converted into platform independent bytecode, and then every operating system has its own JVM that can execute that bytecode. You can visualize it like this. There is a main.java file which will be converted into bytecode, and that bytecode can be executed on different operating system which has their own JVM. So that's why the code is same but only JVM changes. That is the platform independence. So just remember these 3 points. JVM executes the bytecode and manages important running tasks. JRE provides everything required to run Java applications, contains JVM and libraries, provides everything required to develop Java applications, contains JRE and development tools. So the Java complete flow is Java code, it is sent to compiler, and the compiler converts it into bytecode, which is .class file. Then it is sent to Java virtual machine to execute. Then Java virtual machine converts it into machine code, which is sent to operating system, and then we see the output. So the entire process is one of the biggest reasons Java became so successful. As a Java developer, you will hear these terms almost every day, like JDK, JRE and JVM. So it is important to understand them clearly before moving forward. In the next video, we will install Java, set up our development environment, and write our first Java program. From there, we will start building actual Java application. See you in the next video.